Hi, grade 10s. Today we're going to be running through an electricity past paper question. Let's jump right in. So here you can see we have a circuit diagram where the total voltage of the circuit is 24 volts. The switch is open, and in the circuit we have a bunch of resistors. We have two resistors that are connected in parallel and another resistor that is connected in series, as well as an ammeter that is connected in series. So because the switch is open, there is no electricity passing through the circuit right now. So let's jump into the question. So they tell us that switch S remains open, and then they ask us to write down the readings for each of the following, which is our voltmeter and our ammeter. So our voltmeter would still be 24 volts because that is the total energy supplied to the circuit, right? So for A, our answer would be 24 volts. For B, they ask us what would the reading be on the ammeter, and because the circuit is open, like I said, there is no electricity passing through the circuit, so then there would be no current. Therefore, our answer for B would be 0 amps. They then tell us that switch S is closed, so now electricity is flowing through the circuit, and then they ask us to calculate the equivalent resistance in the circuit. The equivalent resistance would just be the total resistance, but we need to take note that we do have parallel components as well as series components, right? So for 11.1.2, the way we would attempt this is to first calculate our resistance of the parallel components, right? In order to do that, we have 1 over resistance, we'll just say RP for parallel, is equal to 1 over R1 plus 1 over R2. So this is our general formula for calculating parallel resistance, right? Then we're just going to go sub in our values. So our resistance value is 8 ohms for the one and 8 ohms for the other. So when we add those two fractions, we're going to get 2 over 8. So 1 over our parallel resistance is going to be equal to 2 over 8. We don't leave our answer like that. What we then do is we inverse our answer. So we're going to swap the position of the numerator and the denominator to get 8 over 2, which is then going to be equal to 4. So the total resistance of the parallel component is going to be 4 ohms. But now remember, that isn't going to be our final answer because they asked us for the total effective resistance of the circuit, equivalent resistance of the circuit. So in order to do that, we need to add our parallel component as well as our series component. So our total resistance is going to be equal to, like I just said, our parallel component plus our series component. So our parallel, which we calculated, was 4. And then you can see that that resistor connected in series is 8. So we just do the sum of those two, and we're going to end up with 12 ohms as our answer. So moving on to 11.1.3, they ask us to calculate the reading on the voltmeter. So there are two ways that this can be calculated, so I'll run through both. The first one that we're going to do, we can use our classic formula, V is equal to IR, which is our voltage, which is equal to current multiplied by resistance, right? So they didn't give us the current of the circuit, so the first step will be to calculate that, right? So we're going to take the total voltage of the entire circuit, which we were told is 24 volts, is equal to current times, and then the total resistance, which we calculated in the previous question, which is 12. Then to find our current, it's just going to be 24 divided by 12, which is going to give us 2 amps, right? Then in order to calculate the voltage of V2 specifically, because V2 is over the 8 ohm resistor, we're going to use the same formula, but now we are just going to use a different resistance. So we're solving for V2. We have our current, which we just calculated, which is going to be 2, and we're going to multiply it by that 8 ohm resistor that V2 is currently over. So 2 times 8 is going to be 16, and then our answer is 16 volts for V2. So that is the one way that we can calculate this. Another way is, if you remember, resistors that are connected in series act as voltage dividers, right? So the ratios from V1 to V2 is going to be equivalent to the ratio of R1 over R2, right? So a way that we can write this is we are looking for V2, right? And we have the total voltage of the circuit. We then are looking at the specific resistance of the 8 ohm resistor that is in series, which let's for this instance say R1, and then we also have our total resistance of the circuit, right? So if we sub those values in, let's just move a little bit up here. We are solving for V2. The total voltage is 24. We have 8, which is the resistor that we're currently working with, and the total resistance of the circuit is 12, right? Then we can just solve for V2. So V2 is going to be 8 over 12 multiplied by 24, and then our answer will also be 16 volts. So there are 2 ways that you can work with this specific type of question. So looking at 11.1.4, they ask us how do the readings on ammeter 2 and ammeter 3 compare with each other? The answer there would just be that they are equal to each other because both branches of that parallel component have equal resistance. So the amount of current going into each of those would be the same. Because in parallel circuits, resistors act as current dividers. So because our resistance is equal in both of our branches of our parallel component, then the same amount of current is supplied to each of the branches. Moving on to 11.2, we have a graph that is showing the relationship between our resistance and the length of the wire. So this is kind of going into the theory of knowing the factors that affect your resistance, right? So if we take a look at the question, 11.2.1, they ask us to write down the relationship between the resistance and the length of the conducting wire. So if you were to just take a look at the graph, you can see that it is a straight line graph that has a constant gradient, and you can see that it is also going through the origin, right? And because of that, because of just that trend and that shape of that graph, we then know that the relationship between those 2 factors is that they are directly proportional. So let me just write that down. 11.2.1, the relationship between the 2 is that the resistance is directly proportional to the length of the wire, right? And just what that means is as one increases, the other will increase. So as the length of our wire increases, then the resistance will increase. Okay, then 11.2.2, they ask us to then determine the resistance of the wire with a length of 30 millimeters. So all you need to do there is go to your graph and actually use a ruler to check where, so we go up at the length of 30 millimeters, and then once we intersect with the line, the graph, we then move across to find the respective resistance. So that would be around 1.35 ohms. And that would be our answer. Cool. Thank you so much. That was electricity.
And cut.